Hi guys, today we're going to talk about an additional way to solve right triangles. Let's review the ones that we already have learned about. So, we have already learned about Pythagorean Theorem. Remember, that is used when you are missing only one side of a right triangle. So when you're only missing one of your three sides, that is when you use Pythagorean Theorem. In this case, you can see we solve for this side, and this actual value here works out to be 10. Special right triangles we also learned about, and this is used when you're missing two sides of a right triangle. And your right triangle has to have either a 45, 30, or 60-degree angle inside along with your 90-degree angle. So in this particular case here, again, these are for special situations. This is your isosceles right triangle. The 45, 45, 90 is the isosceles one. So we know that two of those sides there are going to be equal to each other. So we know that side has to be 4. But we have a formula that says that the hypotenuse is equal to the leg times root 2. So then we just take whatever the leg is, we multiply it by root 2, and that is our missing side. The 30, 60, 90 has some different rules with it. We know that the side across from our 30-degree angle is our short leg. Okay, we know that side is our short leg. And our side across from our 60-degree angle, that's our long leg. And of course, that leaves the side across from the right angle, our hypotenuse. Okay, so in this particular case, we know that the formula says short leg times 2 is going to give us our hypotenuse. So our x value is 10. And our long leg is going to be equal to the short leg times root 3. Okay, but how do we solve a problem that looks like this? How are we going to solve one that looks like this? When you have two angles, or even just one angle, but neither one of them is 45, 30, or 60. You have two missing sides, so you can't use Pythagorean Theorem either. This is when we're going to use trigonometry. So trigonometry is going to be our lesson today. We're going to get started. You're going to use trigonometry when you're missing two sides of a right triangle, or you can also use it when you're missing an angle. That's another option. We can now find angle measurements inside of the triangle. Today we're going to talk about the tangent ratio. We have three ratios, three trigonometric ratios: sine's a trigonometric ratio, cosine, and tangent. And today we're going to focus on tangent. So let's go to our notes. Okay, so in our notes you see this is our first section here on the tangent ratio. The tangent ratio is when we take the leg opposite to whatever angle they give us. This angle A right here, this is always the angle given to you. So from the angle given to you, we're going to do the opposite leg over the adjacent leg. So let's take a look down here in this example. If I say the tangent of A, I'm talking about angle A right now. So from A, where is my opposite? Well, my opposite is this side over here, the 4. That's my opposite. And then that leaves the adjacent. Now I have two sides that are next to that angle A. I have a 3 and a 5. So which one is the adjacent leg? Well, we know that the side across from the right angle, that is our hypotenuse, right? So our hypotenuse is not a leg. The hypotenuse is never the adjacent leg. So that means the adjacent leg has to be 3. So I'm going to put an A there. So now when I set up my ratio, it's going to be a fraction. Opposite is 4 over the adjacent of 3. So that's my trigonometric ratio there that's for tangent. Tangent of angle A is equal to 4 over 3. If I change that up and I now want to go from angle C, from C, my opposite is now 3. So this would now be my opposite, and the 4 would be the adjacent. Again, we don't want to look at the hypotenuse. We want the adjacent leg. So that side right there would have to be our adjacent. So we would have this time 3 over 4. Again, we're creating a fraction here. If you look at the example I have set up over here, from angle A, the opposite is 12, and the adjacent there is 5. So we have 12 over 5, opposite over adjacent. But if we look at the next one from C, here's our C right here. The opposite from C is now over here. So the 5 is now my opposite, and my 12 is now my adjacent. So if I put that one over here, my opposite is now 5 over my adjacent of 12. That's just how to set up the ratio, the fraction. We're going to use those ratios now to solve for missing side values in the triangle. So let's take a look at these examples. First of all, we're going to find the value of the variable, and we're going to round side lengths. That's what we're finding. Y is a side length. We're going to round side lengths to the nearest tenth. That's 1 decimal place. So we're going to use our tangent ratio, tangent of the angle. Now our angle this time is 56. So that's what's going in right here. So I'm going to say the tangent of 56 is equal to the opposite y over the adjacent. So this is my opposite. My adjacent is 32. Okay, so now we have to go to our calculator. And in your calculator, this is where we need to use our tangent buttons. So I'm going to use the tangent there of 56, hit enter, and I get 1.4825. Now I want to take that number out 4 places. The next number is a 6, which means I have to round that 5 up, which means it's going to round to a 6. So the tangent of 56 is actually 1.4826 equal to y over 32. Now I want to create a proportion here. So I'm going to put that number over 1 so that I can cross multiply. Okay, I'm going to cross multiply. So in my calculator, I already have that number up. I don't need to round it off. I can just hit times, and we want to multiply that by 32. So we end up with 47.44. Now, I want to round that off to the nearest tenth. So that's my first 4 there, and the next number is a 4, so I don't need to round. So my y value works out to be 47.4. That is our missing side right there, 47 and 4 tenths, so 47.4. Okay, now let's look at the next problem. I already have that set up. Tangent of the angle is the opposite over adjacent. So from 24, the opposite is x, the adjacent is 20. So we have tangent 24 equals x over 20. We need the tangent of 24 in our calculator. When we put that in, we get 0.4452. And now I'm going to cross multiply. So once again, in your calculator, we have tangent 24 times 20. And we're going to get 8.9. So that missing side length there is going to be 8.9. That's what this one is right here. That is the length of our side. Okay, let's take a look at some more examples. Let's turn your paper over. Now, over here, for this next one, again, we have our angle, 35, and our opposite from the 35 is 10, and our adjacent is x. So let's set that up. Tangent 35 is equal to opposite 10 over adjacent x. Okay, so once again, in our calculator, we need to set this up. Tangent 35, enter, I get 0.7002. Again, I'm taking that out 4 decimal places when I put that number in, equals 10 over x. So again, I want to set that up over 1, and now I'm going to cross multiply. You can see, though, when you cross multiply, you're going to take that 0.7002 and multiply that times x, and the 10 is getting multiplied by 1. So now, just like normal algebra, you're going to have to divide. We have to move this number over to the other side. So we're going to divide by 0.7002 on both sides. That's going to cancel that out. So x is going to equal, and I'm going to take 10 divided by 0.7002, and I end up with 14.28. Now remember, this is a side length we're finding, so we're going to round that off to 14.3. And that is our answer for our side length right there. Okay, let's take a look at the next example. Same thing. You have the 21-degree angle. From the angle, opposite is 30, adjacent is x. So the tangent of 21 equals 30 over x. We found here that the tangent of 21 is 0.3839. And now we need to cross multiply there. And when you cross multiply, you end up with 0.3839x equal to 30. And once again, I'm going to have to move that over to their side. So I'm going to divide by 0.3839 on both sides. And when I do that, I end up with an answer of 78.2 as my answer. Okay. If you use in your calculator, if you end up taking 30 divided by, and you can do this, the tangent of 21, oops, wrong number, 30 divided by tangent 21. You'll see there that that will round to 71 or 78.2 there. So again, 78.2, if you simply take 30 divided by 0.3839, you'll see there that you get 78.1. Either answer would be acceptable there, okay? All right, now let's look at the next example. This is a little bit different. If you notice, I don't have an angle this time. But y is still the given angle. Y is still the given angle. So that y right there is going to go in for that angle measure. So we're going to set that up. The tangent of y equals. Now from y, this time, my opposite is 8. That's my opposite. And of course, my adjacent is the 5. So we're going to set that up as 8 over 5. Okay, so now how are you going to solve this? you can't really put that tangent y in your calculator just yet. So what I'm going to do is I'm going to take 8 divided by 5, and I'm going to get a decimal, 1.6. So this is what I have. Now, I can't really do anything with that, but if you think about algebra, typically in Algebra 1, right, you learned we're going to divide both sides here. Now I'm going to divide by tangent on both sides so I can get that y by itself. Now that looks a little awkward. So what we're going to do is I want you to recall this concept from Algebra 1, 1 over x. We can rewrite that. If we move that x up, that becomes x to the negative 1. Well, we can do the same thing here. We can move that tangent up, and that's going to become tangent to the negative 1 of 1.6. Now, in my calculator, I need to come up with that tangent to the negative 1. So here's what we're going to do. We're going to hit, if you look at the tangent button on your calculator, right above the tangent button is a tangent to the negative 1. To get that, I have to hit the second key. See, the second pops up, and then I can hit the tangent button. And there's my tangent to the negative 1, and then I can type in 1.6. Now, these are angle measures we're finding. If you notice, it says round to the nearest whole degree. So I'm just rounding to the nearest whole number. That is going to be 58. So that right there is going to be y equal to 58 degrees. We just found the value of y. Just remember that that tangent to the negative 1 is found by pressing the second key and then the tangent key right after, and that will give you that tangent to the negative 1 there. All right, let's go to the next example. The next example looks a little awkward because you have a number on the hypotenuse this time. You don't need it. We're using tangent, and the tangent ratio does not require the hypotenuse. When we learn about sine and cosine, you will need the hypotenuse for those. Right now, we don't need it. We're just going to cross that out and not even look at it. So, from x, I'm going to set this up. Tangent of the angle x is equal to the opposite 6 over the adjacent of 8. Now, when I do that, once again, I'm going to have to move that tangent to the other side. So I'm going to show you a little shortcut this time. Instead of dividing the 6 divided by 8 out, I can simply take my calculator, hit second tangent, and I'm going to put right in there 6 divided by 8. And there would be my answer. I don't actually need to divide the 6 divided by 8 and get the decimal unless you really want to, but you can do it all in one step. So that becomes 37 degrees there for that angle measure. Okay, let's take a look at the bottom example. In the very bottom example here, you see that it says the base of an isosceles triangle. Okay, key word is isosceles there, so we know these two sides are equal. Okay, it's also asking us about the altitude. Now, the altitude is the length that drops down at a 90-degree angle, right? We learned about that. And it says the altitude to the base is 60. So this measurement right here is 60. Find to the nearest degree the measure of the base angles of the triangle. So that means these are the base angles in our isosceles triangle. Now, let's recall the concept of altitude. When you have the altitude in an isosceles triangle, not only does it form the 90-degree angle there, it also divides the base in half. So both of these little lengths here are going to be 40. Now we just created a right triangle. We're going to focus on just one of those right triangles where we have a length here for the altitude of 60. Half of that base there we said was 40, and we're trying to find this angle measure right here. That's our x. So we're going to do it just like we did the problems above. So from the x, the opposite is our 60 and the adjacent is our 40. So the tangent of x is equal to 60 over 40. Okay? So once again, I've got to move that tangent over. X is going to equal tangent to the negative 1 of 60 divided by 40. So I'm going to put that right in my calculator. Second tangent, 60 divided by 40, and we end up with a 56-degree angle. Remember, we're finding an angle here, so we're rounding it off to the nearest whole degree. Okay, just a couple of quick notes. Remember, when you're looking for an angle, you need to use that tangent to the negative 1 when you're trying to find an angle measure. And again, that's how we put it into our calculator. If you were confused by anything here, just go back and rewatch the video. Good luck.